What's up, guys, and welcome back to Math with McKay. All right, so here on my board, I have two words, right? But they seem to look different, but they are the exact same thing. So when we talk about the multiplicative inverse, all that means is the reciprocal. And what we remember from what we've been teaching thus far, reciprocal is flip, right? So all they are saying, when you see the multiplicative inverse just means opposite. It's the same thing as them saying the reciprocal flip. So whatever fraction they give us, all we have to do is flip that fraction. So here, if I give you, let's say, 2/3, the multiplicative inverse or the reciprocal of 2/3 would be 3/2, right? So if they say multiply by the multiplicative inverse, what this means is that our goal is that when we multiply these two numbers across from each other, it equals a whole. So here we have 2 times 3 is 6. Then we have 3 times 2, which is also 6. 6 divided by 6 is equal to 1 whole. So whenever they say multiply by the multiplicative inverse, that just means take the opposite and multiply it by each other, right? So we'll do one more example. So if we have 3/4, the inverse of, or the multiplicative inverse, multiplying by the inverse, would be multiplying by 4/3. This is the reciprocal. Remember we do the keep, change, flip? We flip this fraction to get its reciprocal. When we do that, numerator times numerator gives us 12. Denominator times denominator also gives us 12 for an answer of 1 whole. Now that's just the beginning of what we're going to focus on today. Today we're continuing to multiply fractions by whole numbers and mixed numbers and things of that sort. So if you look at page 73 in your student workbook, it says model the following using the partitive representation. So they give us 3/4 divided by 2/3. Now remember, when we talk about partitive, we're saying 2/3, excuse me, that's supposed to be 2/5 of what number is 3/4. So we're trying to find the whole, right? So how we would model this is we would go ahead and we would take this tape diagram, right? So the question at hand, the question that we're trying to focus on is 2/5 of what number is 3/4, all right? So here, we don't know the entire thing. We're trying to figure out what all of this is represented by. And that's supposed to be a question mark, okay? So then we would go from there, right? First thing it tells us to do is, it says shade 2 of the 5 sections. First of all, we got to take this this tape diagram and break it up according to the second fraction. So here we have, I need 4 lines to get 5 sections. Then we shade in according to the numerator. So it says shade in 2 out of that 5, okay? And this part is saying that it is equivalent to 3/4. This is what 3/4 is equal to, right? We're trying to figure out what the entire thing is, right? So now that we've gone ahead and labeled our parts, right, we're trying to figure out what this entire thing is. So then we would go ahead and we would work this out manually, right? We would say 3/4 times the inverse or the reciprocal of 5/2, okay? Then we go ahead and we multiply numerator by numerator, which gives us 15. Then we go ahead and do denominator by denominator, which gives us 8, okay? Now this is an improper fraction. We could leave it like that if the answer choices are in the form of an improper fraction, or we can go ahead and take this out of the improper fraction form and make it into a mixed number. How you take an improper fraction and make it into a mixed number? You take the divisor and put it on the outside. The numerator is your dividend, and you see how many times can this divisor go inside of the dividend. How many times will 8 go into 15? 8 will go into 15 without going over one time. This now is going to serve as your whole number. Your quotient serves as your whole number. Then I say, well, what's 8 times 1? That is 8. 15 minus 8 is 7. Your remainder becomes your numerator, and your divisor remains as your denominator. So 15 eighths is the same as 1 and 7 eighths. And that is what the answer would be. All right, so now this was using the partitive form. We'll do another example where we do the measurement form, okay? And when we talk about the measurement form, you say, for example, if we're doing, let's say 3/5 divided by 1/4, okay? When we talk about the measurement form, it says 3/5 is how many fourths, right? So I would go ahead and I would draw my tape diagram. And this is how we would show it using a visual, okay? Notice I have a whole bunch of lines in this. Some of you might be trying to figure out, well, how did she get those lines? What I did for this, before I went ahead and multiplied or divided or anything like that, I found the least common multiple. What's the smallest number that they both have in common? So now multiples is you take two numbers and you multiply them together, and those will become multiples. So multiples of 5 is like 5, 10, 15, 20, and 25. Those are multiples. So what multiple do they both have in common? In this case, they both have 20 as a common multiple, right? So then we would go ahead. We would change this division problem to a multiplication problem, because that is how we do that. So here, this entire part, we would shade in, I would convert, so we would go ahead and convert one of these fractions, or convert the fractions to the same denominator. So how I would do that is I would take 3/5 and multiply both the numerator and the denominator by 4 in order for us to get 20, right? So this will be 12 out of 20. Then I would take 1/4 and I would do the same thing, but instead of us multiplying by 4, we multiply by 5. And this is how you would get the least common multiple. You can take the denominators and multiply them by the opposite fraction. So we get 5/20, all right? So those are the two numbers that we would go ahead and we would work with. So instead of you saying 3/5 divided by 1/4, it's still the same thing as saying 12/20 divided by 5/20, okay? So what's shaded in, we take this fraction here and we shade in 12 out of the 20. This would represent our 12/20, right? And then we would go through and we would break what's already shaded up according to this second fraction. And this second fraction is 5/20. So let me go ahead and write this 12/5/20, right? So I would go through and I would count out 5s, right? Count by 5s, right? So 1, 2, 3, 4, 5. This represents 5 out of 20. 1, 2, 3, 4, 5. That represents 5 out of 20. Then we go through and we still count out 5 for what's remaining, right? 1, 2, 3, 4, 5. That represents, it's not a whole 5. We don't have, I mean, the whole thing would represent, of course, 5 out of 20, but all 5 are not shaded in. We would only focus on what is shaded in. How many of the 5 is shaded in? So we created 2 groups, and then 2 out of the 5 was left over. Now that may or may not make sense to you, so let me go ahead and do it without this, right? We'll do the same thing that we've been doing. Keep the first number, change the division to multiplication, and then take the reciprocal or multiply by the opposite, flip the second one, right? So we'll have 3 times 4, which is 12. Then we'll have 5 times 1, which is 5. Here we have an improper fraction. So how we create or take an improper fraction out of that form, we take the denominator and put it on the outside, that is your divisor. You take your numerator, put it on the inside, that's your numerator. How many times will 5 go into 12 without going over? 2 times. 5 times 2 is 10. 12 minus 10 is 2. This serves as your numerator. This is your denominator. This is your, all right, so this is equal to 2, that's the whole number, the denominator. The same exact thing that we did when we worked on it the other way. I want to show us this using just that one rectangle, and I know a lot of us were still kind of confused with that. So I'm going to take this and I'm going to break this up according to the first fraction. So the first fraction says 3/5, so I need 5 columns. Remember, columns and rows. 1, they're my 5 columns. Out of those 5, this numerator says that I only have to shade in 3. So I'm going to shade in 3 completely. There's my 3/5, right? Then this second fraction says that I need to break this up into rows of 4. So 3 lines will give me, right? And then of those rows, how many are shaded in completely? So I'm going to go from top to bottom, all the way through to the end. If we pay attention to the sections that don't have the overlapping parts, that tells you how many of those particular things are in there. That's how we can break it down based off of the fraction. So if I were to give you this, and we have to figure out what is the fraction or what fractions are being used based off of this right here, I would check to see what's shaded all the way through. What's shaded all the way through? How many columns are there? That tells me my first fraction. What's shaded all the way from left to right? How many rows are there? And that's how we would get our second fraction. So whenever we're doing this, you want to make sure that you're paying attention to columns and rows, all right, in order to come out with the correct answer.